Hey, platform engineers. Welcome to my talk, where I would like to share my journey into Wardley mapping in the domain of platform building. My name is Andrey, and I work as a consultant and a fractional CTO, and my position often requires me taking both technical and strategical decisions, engineering decisions. So I'm always in the search of tools that will help me visualize decision making or help facilitating discussions around those decisions. Quite often, decisions fall into category of how much we should build ourselves using our software development capacity, or how much we should actually delegate to an external product or vendor. One tool that helps me with that is so-called purpose alignment metrics. Basically, we can look at anything from the perspective of how it differentiates us from the market players and how mission critical it is for our business or team. If we choose to buy in the domain of platform building tools, there are many shopping options to choose from. Which one is better? Which one gives us faster path to the features we need and bring us more focus? Of course, there is no single answer to that. On the other hand, often as engineers, we may forget about to explore the existing opportunities and actually start building stuff, which could be a good thing and a bad thing at the same time. There's a famous IKEA effect that could be both the right path and a trap, because we as engineers may fall in love with what we have participated in building too much to see the situation around us. Of course, we have to start with why we're building the platform that we're building, and approach that as a product. But that's nothing new for experienced platform builders out there. Your platform evolves from a small MVP that solves some problems into mostly invisible mechanism that allows smooth and focused software delivery. It takes time and effort. It will not get there from the first version. One trap that I've seen some platform teams are falling into, they try to create an ideal platform from the very beginning. And then they lack adoption of that platform because developers needed something else. Sounds familiar, right? Waterfall. Another thing that I've noticed that was catching up some platform teams is their belief that some custom UI or internal development portal is an absolute requirement for the platform. Well, it's not, at least not always. We have to meet our users or our actual developers where they live in their habitat. And that's most likely will be more tech-friendly tooling. Git or Git ecosystem, for example, pull requests, GitHub integrations is a convenient way to get feedback and interact with the platform. Command line tools, CI/CD pipelines will be most likely the first line of response to any issues. So it's important to make it align with the platform, right? So developers also most likely would like to look in dashboards that have useful data in that and useful integration that help them understand what's happening. Uh, so in terms of investment of platform engineering time, uh, it is probably more beneficial to make investment into interfaces that are closer to the place where users have natural interactions, which in our case is more tech-friendly tooling. Uh, Another trap that many engineers fall into is having a strong opinion on which tool is the best and then forcing it. Whenever we make a decision, we need to take into account the context, and certain tools will introduce more fluctuations and most likely require some relearning before they're efficient enough. Platform tool choices that you see on the slide could be good enough for the context in which they're used. Of course, we can have our opinions about each one of them, absolutely, but the context is the king here, which can bring more value to the actual business that is using that platform. Okay, so a lot of decisions in platform engineering are strategical because they will affect developers who create value for the end users, and we don't have much time to invest into the wrong direction based on incomplete assessment of the context or market. So strategy is hard and did. Some time ago, Simon Wardley introduced his mapping techniques to help with strategical decision making. And not only that, he also noticed that, and I agree with him, by the way, that we quite often make our decisions based on simple, flat, and generic bullet lists from someone else that often is missing valuable context. Just imagine this chess strategy. It may help you win the game, but obviously only few potential boards would work, and we still don't know how exactly the pieces should be moved. No context, no direction, no clarity. The next picture looks more precise. We see where the pieces are. We have some winning idea there. We know which threats our opponent creates. We also use domain-specific notation that professional chess players will definitely understand. So several elements that make it way more clearer than the previous picture. So what is a map? Simon defines that by six important properties. It's visual, Context is defined, components are defined, their position attached to an anchor, and potential movement of components has a meaning on the map. So basically, six main elements: visual, context, position, anchor, movements, and components themselves. So just look at the typical transportation map. City is the context, a river is the anchor, stops and routes are the components. Changing position on any component will make it a different map that doesn't represent the reality anymore. We can also put ourselves on that map and describe our movement through the traffic system in terms of initial location and target destination. The path depends on the map and our goals. Right. So yeah, let's start with empty canvas. In Wardley mapping, the map contains two dimensions. One axis is value chain. So basically, that's how visible the component is to the users, to our target audience. And another axis is the product maturity or evolution. We're starting with Genesis, then we jump into the custom build stuff, then we reach the product phase where we can purchase or rent the product, and also then comes like the full industrialization phase when the product turns into a commodity and can be replaced by any other thing on the market that fits the same interface. For example, electricity provider as one of the popular examples in there. So at the top of the value chain, we have our users. In our case, of course, it will be developer. User have needs that are realized by components in our system, and you can think of that as a UML use case diagram if you ever seen them before. So there are many different notations that can be used on the Wardley map, but I prefer to use these four simple elements: a component relationship, an impediment, and an upcoming change in the component state, which usually represented by an arrow. So let's start mapping. So of course, our main customer, as I mentioned, for main customer for platform builders will be a developer. And any reasonable organization most likely will have different platform elements in different stages of evolution. The direction of change that we most likely want to achieve is the full platform industrialization to save on costs and focus on the business. But obviously, we're not there yet. At least I haven't seen any real company where this would actually happen. No full industrialization of the platform yet. And if we start, drawing our components from top level touch points between our developers and the platform, we can start mapping other elements that participate in building that and connecting that. For example, we can mark, we can put a mark. There are some. There's a bunch of custom built infrastructures called artifacts that we use to provision the base layer of our infrastructure. Developers may not see that, but it still affects them. Also, the app deployment, for example, for the app deployment, there will be a Kubernetes cluster. Let's imagine that, which is a product, and we configure that product and we use that product. Also, potentially, maybe our developers are using some serverless deployments and they use our Lambda function. So they don't really need our platform, maybe with some guidelines, but they basically use the interface from a cloud provider, which is highly industrialized and well, maybe in some way replaceable with other cloud providers, right? So that's one way to look at that. We can also continue mapping that, and we can go down and kind of also find, certain things that may be completely not visible to the developer, but totally visible to us. For example, we can admit that we have some custom GitHub workflows, but we would really like to migrate to a new and shiny Argo CD way of doing that thing. And we can also realize that there is an impediment on that change, right? So maybe there's like some security requirements that we need to address before we do the migration. And of course, we have to probably address the learning curve that requires that. Also, we have to consider how visible this component will be to the developers. That's a lot of things to discuss here and to introduce to the teams that are involved in building that platform. And some of those teams maybe are not aware what's happening behind the scenes. Another thing that could happen here is that, as you can see, there's another impediment of migrating from in-house Kubernetes cluster, which probably was built a few years ago, into a managed Kubernetes cluster. And again, there could be some impediments in terms of learning curve, in terms of security assessments, and many other things. Maybe there is some specific components that were built keeping in mind our internal infrastructure, something that will not be available in the managed cluster that we've, let's say, set up in Amazon or Azure. And there's another problem that we can probably notice on this map is that it doesn't really fully represent the reality on the top level. Because imagine, like, no developer ever has come to the operations room and said, I need a platform, right? Because usually they need something more specific, something that helps them in their workflows. So, for example, they probably need a self-service environment, right? And so we can start mapping from that point because it's more closer to the user. It's actually what they actually need. And from there we can start realizing that okay, developers will actually have some sort of self-service environments that, and they use some custom UI for that. That was probably built some time ago by some brilliant platform engineer. It was useful, but it requires fixing and has some long-standing bugs that annoy devs. So as it appears, the ants also could be that actually the ants that are created by this custom UI actually not using the Kubernetes cluster that was in the game in the previous mapping. Actually, they're using some custom built virtual machine templates, and that's fine. It's kind of working for some part of the workflow, but it doesn't really play well on the big picture, serving the needs of developers and integrating with the change processes that are happening inside the platform team. So we need to kind of align those things. So of course, we need to do something, to migrate those custom VM templates to Kubernetes cluster. But there's definitely an impediment because there's misalignment in the things that developer use and the strategy that we put in our platform team on the previous map. Another thing that kind of may become obvious when you start mapping this stuff, that the custom UI that was introduced is actually not following what's happening in the industry. Because at least from my perspective, many teams are migrating their workflows, the platform interfaces to GitHub system, to GitHub, to GitLab, and they integrate their touch points with the developer in there. And there are many plugins, there are many chatbots, there are many integrations that exist out there already, and they're already ready to be used. So instead of creating something custom and integrating something custom into your workflow, maybe you should consider using some existing functionality that would already serve a lot of developer needs, and actually will reduce the burden on the platform team because you will just use the things that are more productized, more industrialized than your own custom built features of your platform. Right. So there's a lot of things that you can discuss actually when you start surfacing these elements of the platform, elements of the strategy, elements of the external world and internal world, and that's the beauty of the map. Right. In conclusion, my experience with mapping is that initially people could be a bit skeptical of them, but then when the useful discussions grow up from those maps, that's what the most valuable asset that you get. The map itself may become useless after you have a discussion, but the common understanding that you get from that's the biggest benefit, because it raises your situational awareness both for internal situation and external market. You can make better decisions, and you can easily repeat that many times. So yeah, draw maps, draw many of them, and use that as a facilitation tool. So yeah, thank you very much for your attention. Also, another goodie that I have to mention, of course, is that Simon actually has a book about mapping. This book is under a Creative Commons license, so it's completely free. And it's really worth reading and looking at what Simon has came up with in terms of strategic mapping and different techniques that he used to visualize in his journey. Thank you very much. My name is Andrey. If you found this topic interesting, feel free to connect with me on socials, and yeah, let's discuss this more. I'll be happy to see more mappers in the community, and community of mappers should be growing. Thank you very much.